everyone, in this video we're going to go through the solutions for the Maths Methods test from week 1. So just 4 questions. I'll try not to make it a long video because it shouldn't really take you too long. So if you're grasp these topics, you should be able to move through these solutions quite quickly. Alright, now the solution's already up, so let me choose a different colour to just go over it in. Okay, so question number 1. A straight line is perpendicular to the line that passes through the points 2, 5 and 8, 2. So this is important information, so I'm going to circle that. If the line passes through the origin, also important information, then we've got to find the equation of f of x. So another bit of information I should have circled is perpendicular. So we basically have 2 lines and we don't know what they look like, but we've got one straight line that goes through the 2 points 2, 5 and 8, 2. So let's just say there's 2 points here. And the line we want is perpendicular, and it also goes through the origin. So what it means by going through the origin is this point here is 0, 0. So that already tells me that my equation is going to be f of x equals some gradient, which we'll work out in a sec, plus 0. All right, your y-intercept is 0, so it's just plus 0, which makes this question a little bit more straightforward than probably others if you had to have another point. Or if you had another point, sorry, not 0, 0. Okay, so just remember the origin is 0, 0, x equals 0, y equals 0. So you can see in my solutions, I've calculated here the gradient of our first line. It's -1/2. If we want a line, the gradient of the line perpendicular to that line, it's the negative reciprocal. So basically we take our gradient of -1/2, we multiply it by a negative, which gives us a positive. So basically one gradient is going to be negative, the other one's going to be positive, and we flip. So 1/2 becomes 2/1, and we don't usually write 2 as 2/1, so your gradient is 2. So pretty straightforward. Your line is just f of x equals 2x. All right, question number 2. So there are 2 ways of doing this. I do prefer doing the ratio of the coefficients. You can rearrange them to get them in the form y equals mx plus c. Now I do think the way that I've done it is more straightforward than rearranging it in the form y equals mx plus c, because if you're rearranging it, so what I mean by that is we rearrange it into the form y equals mx plus c. So let's call that equation 1, and your second equation is here. So basically if they were the same line, so if they had infinite solutions, those 2 equations would be the same. If they were parallel, they would have the same gradient but different y-intercepts, and if they had a solution, they would be completely different gradients. Now, perfectly fine doing that, but when you're working with transposing, and often you're given the questions in this form, so it means you have to transpose them into y equals mx plus c, we're prone to make errors. Okay, so just keep that in mind. That's why I prefer this method. So this method, we're just taking the ratio of our coefficients. So the coefficient of x here is m, so you can see, and I might choose a different color, highlight in blue. All right, so we've got the blue, so there's the m, and then over the coefficient of x in your second equation. Now, if they're the same gradient, these 2 will be equal. Okay, so we want the same gradient because they're parallel. All right, parallel lines have the same gradient. If they were the same line, they would also have the same gradient. But we've got to check later on whether they're parallel or the same line. All right, is equal to now the coefficients of y. So you can see, just highlighting here so you can see where everything is. So I do that, and then I've got to find out what m is equal to. So m is equal to -4 and m is equal to 2. Now, that information just tells me that these have the same gradient. So when m equals -4 and m equals 2, they have the same gradient. And that could be, they could be parallel lines, all right, because parallel lines have the same gradient, or they could be the same line. So we have to do one more check to see which situation it is, okay? Because all we know now is there's no unique solution. If the question wanted us to answer the unique solution, so unique solution, we can say, all right, we want m to be an element of any real value, excluding -4 and 2. Because if it was -4, it's a parallel line, all right? It's not going to cross. If it was 2, it would be a parallel line, or the same line. It's not going to cross. So for a unique solution, so unique being 1, all right, you can have absolutely any number your little heart desires except for -4 and 2. But that's not what the question's asking. It is asking us to have parallel. All right, so no solution. And this is where, and let me highlight this in a different color, not pink because I write in pink, purple. All right, we've got this 10 and the 2. Now, if they were the same line, this 10 over 2, which I've written here, would be in the same ratio as either m over 4 or 2 over m plus 2. All right, they give you the same thing. I've just used m over 4 because it's a little bit easier. So you can see I've just substituted in -4 where m would usually be. You can see they're not equal. So when m equals -4, they're parallel. If it was, say, let me just write here, if it was not 10 over 2 and it was -1, then clearly -4 over 4, they're equal. All right, and that would mean infinite solutions. They're the same thing. All right, so then we do our check with m equals 2 because we did have 2 solutions. Remember we had -4 and 2. So I've just got to do another check and you can see that 2 is not equal. So m can be -4 and it can also be 2 for our lines to be parallel. They will never be the same line. And if you wanted to have unique solution, remember this is your answer. All right, just moving on to question 3. So transformation. So we're going to do transformations a little bit later, but I remember doing this back in when you guys were in year 10. So when you're reading transformations of a quadratic, all right, so we've got a quadratic here, and you'd only go from one quadratic to another quadratic or type of graph to another type of graph. All right, you don't change the type of graph. You don't go from a cubic to a quadratic or a linear to a quartic or anything like that. Okay, so we're sticking with a quadratic. Now, if you're looking at a quadratic, the easiest thing to do is to get it into turning point form. So you want to complete the square. So in this case, we have to expand first. We have to expand that quadratic because it's currently in factorized form. We need to complete the square to get it into turning point form and put into turning point form. I'm just going to write TP form. So if we have a look at this, it's a bit of a messy one. First of all, you can see I've changed this, 1 minus x to -x plus 1. I just prefer the x first. You don't need to do that. But I can see that my leading term is a negative. All right, so your leading term with the highest degree, the highest power. When you're completing the square, it has to be with a positive. So I've just brought that negative out the front, and you can notice that my signs have changed, okay, because I brought that -1 out the front. So all I'm doing is completing the square with this quadratic here in the brackets. All right, so somewhat of a tricky one to do. First of all, because of that negative there, but we do end up with this 25 over 4. So if you're adding a fraction to a whole number, like we were adding it to 4, I've just rewritten that 4 as 16 over 4. Just enables me to add those two fractions together. So -25 over 4 plus 16 over 4 gives me the -9 over 4. Now one last step, I do have to multiply this negative in. So that negative applies to our bracket and also to that -9 on 4. So important here, it becomes a plus. When you're reading your transformations, try to do your dilations and reflections first. So I always say DRT or Dr. T. You can do reflections, dilations. If you do it translations first, and it doesn't mean that it's necessarily wrong, because you can have different ways of getting from one quadratic to another quadratic. It's like if I was to walk from school to the train station, I could go directly across the road, or I could cross over to Coles and then walk around past Just Italy, or I could walk down past, Mentone Grammar. All right, you end up at the same spot. You've just got a different way of getting there. So you've just got to be careful the order. Now, if you do have it in turning point form, then you do follow DRT. Okay, so dilation, reflection, translation. You can do reflection, dilation, translation. All right, so this negative means it's been reflected in the x-axis. So remember, you can be reflected in both the x and the y. So make sure you've got the correct axes. And then this 5 on 2 means we're being translated 5 on 2 units in the positive direction of the x-axis. It looks like this has just gone down a little bit. Sorry about that, guys. And then this 9 on 4 means it's gone up 9 on 4 units. So we do say in the positive or negative direction, not up, down, left, right. Okay, so just a reminder, you're probably sitting there like, oh yeah, I remember that. And all is good in the world. Okay, last question. Oops. So this is what happens. Okay, let me just undo that because, oh man, where are you? Where is my undo button? So I'm going to, okay, just have to flip my computer back. Yeah. Control Z, go back where you're supposed to be. Okay, let's start again. Okay, go back up. Read the question. Okay, so explain why the following quadratic will always have two solutions for k is an element of R. So k is any real number, basically. So we know if it always has two solutions, it is always going to cross that x-axis. It's not going to sit on it, it's always going to cross it. So if we've got two solutions, it means your discriminant, here we are, has to be greater than 0. Now, this is more typical of a SAC question. It requires you to think about what is actually happening, and most of you were able to get the discriminant, which is, if we just left it as k squared plus 16. Now, because k squared plus 16 has to be greater than 0, we're not solving for k, we're explaining why we will always have two solutions. So basically, k squared plus 16 will always be positive, because no matter what number you have for k, squaring it is going to give you a positive. So let's say, for example, we let k equal -2, squaring that, it's going to give us positive, whoops, wrong place for the 4. Squaring that is going to give us 4. Or if we had k equals 2, squaring that is also going to equal 4. So no matter whether it's a negative or a positive, it's going to give you a positive answer. Sorry guys, a spam caller just called my phone. Yeah, so basically something along those lines is what you need to write. Basically, k squared plus 16 is always going to be greater than 0. If you wanted to see what this looks like graphically, you can put it on your calculator. And I want you to get used to using your calculator, which I don't have here. Let me just pop it on up. Don't know how to do it. There we go, should it be in this menu? Using sliders, because in your SAC, if you're using sliders, then, come on guys, then you can visually see what's happening. Take your time. Okay, so graph, all right, let's get rid of what's there. So I'm just going to, what am I going to do? I'm going to clear all. All right, so if we just put in what is there, so 4x squared plus, and it's going to have to shift you up a little bit, so get the keyboard out. Where am I? K, so my computer doesn't always like it, so I'm going to flip my computer back. What are we doing? K, did you press it? Thank you. Okay, times x minus 1. All right, so just double check that you've put it in correctly. We're going to tick it, and this second one is going to add the slider, so you can see the slider here. Now, if I go to autoplay, we can see that it's never crossing that axis. It's like jumping around, which is pretty cool to see. All right, so no matter what k is, it's always going to be two solutions. All right, we can change those values of k. So if we go to settings, instead of going from 10 to -10, maybe let's do 1,000. I wonder if this is going to jinx it. Oops. And let's do a step of 10. I wonder what, oh, what did I do wrong? Value, oh, value. Radio. Whoops. Silly me. Wasn't really paying attention. Okay, that should work now. So if we go to autoplay, all right, oh, we can't really see it. That's the value of k. So when we did this the other day in class, some of you were like, oh, it's only crossing once. It's only because we can't see it, and I probably shouldn't have chosen such a high value. So I wonder if we can stop it. All right, if you do want to stop it, just press clear. Okay, so probably too high a value, but do remember, if you're only seeing it once, the parabola still exists, it's just off the screen. Okay, all right, get rid of that. I think that's it for that one. 15-minute video, awesome. All right, girls, thanks.